Hello everyone, welcome to our channel. Today I am going to explain you a chapter from class 12. I am going to explain you inverse trigonometric function. So what is the planning for the entire chapter? First, I am going to build up the concept that requires little bit revision from trigonometry and some information from relation and function. So we'll discuss that part. That will clear your concept when the function is invertible and under what condition trigonometric function is invertible. In the next part, which is important, I am going to discuss the formulae and tricks to remember all those formula. And in the subsequent part, I am going to solve some problem. I will try to cover up as many as problem I can. So this inverse trigonometric formula, this will series 8 to 10 parts. So I hope at the end you will familiar with the chapter and you are able to solve the problem of your own. So let us begin the journey. Inverse trigonometric function. So first, let me recall the fact, or if you miss some content, so it will be brush up your content, previous content. When a function is said to be invertible, that means under what condition inverse of a function exists. So the first topic of our discussion is inverse of a function. Inverse of a function. Now, a function is invertible, or if a inverse of a function exists if the function is 1, 1 and onto. If a function is 1, 1 and onto, then only inverse of a function exists. Now what is the meaning of 1, 1 function and what is the meaning of onto function? Let us discuss first 1, 1 function. 1, 1 function. Now, take one example. We consider two sets A and B and a function f maps from A to B. A function maps from A to B. Now, we know this is called as a domain set and this is a codomain set. Now, for every element in the domain set, if there exists a unique image in codomain set, then the function is said to be 1, 1 function. x1, suppose x1, x2, x3, x4 maps to y1, y2, y3, y4. So for all element belongs to the set A, if there exists a unique image in set B, that is codomain set, then the function is said to be 1-1 function. The name itself suggests 1-1, that is every point have its unique image in codomain set. So we remember this 1-1 function as every point or every element or elements have unique image in codomain set. Moving into onto function. Moving into onto function. Now, again we consider two sets A and B. F maps from A to B. Now, in 1-1 function, we are checking every element of set A, that is a domain set, have their image, unique image in B. Now, in onto function, we check every element of codomain set have their pre-image in domain set. If every element of codomain set have their pre-image in domain set, then the function is said to be onto function. So we write it as every element or elements of codomain set have their pre-image in domain set, then the function is said to be onto function. That means if we get two elements have same image in 1-1, if we find out x1 and x2, for example, have same image in B. For example, if we take fx is equal to x square, fx is equal to x square, so f of 1 is equal to f of minus 1 is equal to 1. Now see, there are two elements 1 and 1 in domain set, they have the same image in codomain set. So this is not a 1-1 function. Then if it is not a 1-1 function, then we called it as a many one function. It is a many one function. And if you get a point, suppose if you get a point whose pre-image does not exist in domain set, if you get at least one element in codomain set whose pre-image does not exist in domain set, then it is said to be an into function. So into function means you get at least one point, whose pre-image does not exist. whose pre-image does not exist. I think I am clear with the concept. Sit with your pen and pencil, rewind the video, write the important notes so that when you solve the problem, you will not find any difficulties. Now, let us discuss one sum based on 1 function and onto function. Because I tell you that inverse of a function exists if it is 1 and onto. That is, if the function is bijection. Now, here the function is given as fx is equal to x upon x plus 2. X upon x plus 2, and the range is, here domain is given as -1 to 1 maps to R. Now, to prove 1, we apply method of contradiction. In method of contradiction, we consider the opposite one as a true. So, if it is, we need to prove it is 1. So, if it is not 1, so it should be many 1. So, in method of contradiction, we assume that the function is many 1. So, we start our problem at let, if possible, fx be many 1 function. Fx be many 1 function. So fx is many 1 function, so we consider two elements x1 and x2. x1 and x2 belongs to -1 to 1. That is domain, where x1 not equal to x2. So many 1 function means for two different value of x, output will be same. So it implies fx1 is equal to fx2. fx1 is equal to fx2. So, how we proceed the sum? Because this sum is there in the relation and function exercise. To explain you the built up concept for inverse trigonometric function, I take up this topic so that I brush this entire thing, the entire content to you, so it will be comfortable for you to move into the chapter. So, fx1 is equal to fx2 means fx is equal to x by x plus 2. So fx1 is equal to x1 by x1 plus 2 is equal to x2 by x2 plus 2. Now we apply the cross multiplication. So if you apply the cross multiplication, so you will get x1 x2 plus 2x1. If you multiply these two, is equal to x1 x2 plus 2x2. Now x1 x2 and x1 x2 will get cancelled. These two will cancel with these two. So it implies x1 is equal to x2. Clear? Now see, we reach to a point of contradiction. Why? Now after this we are getting x1 is equal to x2, but our assumption is x1 not equal to x2. So therefore, which is a contradiction? So we write which is a contradiction. Hence our assumption is wrong. We reach to a point where we contradict our previous assumption. So hence our assumption was wrong. Therefore fx is 1, 1. Now, so we complete the first part. Now find the inverse of the function. To find the inverse of the function, we need to prove the function is onto. So the process is, we assume let y is equal to x upon x plus 2. That means there is a value, output value, or a point or an element we are taking from the codomain, and we are trying to find out pre-image of y, that is the value of x. So from here we find out the value of x. So if you cross multiply, we will get xy plus 2y is equal to x. Now bring this x here. So xy minus x is equal to minus 2y. Now from here, if you take minus x common, so you get 1 minus y is equal to minus 2y. Therefore, x is equal to this minus and this minus will get cancelled. So you get 2y by 1 minus y. And 2y by 1 minus y, this type of form is always there in the R. So you say it belongs to R. It belongs to the set of real number. Therefore, f inverse of x is equal to 2x. Replace the variable by x, 1 minus x. Clear? So, inverse of a function exists if the function is 1, 1 and onto. Next, so this concept we require in inverse trigonometric function to build up the concept how we are getting the inverse of a trigonometric function, and then we require the domain and range of a trigonometric function. So let us discuss the domain and range of a trigonometric function. Now I am going to discuss or recap the concept of domain and range of trigonometric function which you learned in class 11. Now first, sine and cos. Domain is R. Domain is R. That means sine and cos is defined for all real values. So sine and cos domain is R. So you just need to make a pair, so it will be easier for you to remember. Sine and cos domain is R. Sine and cos domain is R. Now look at the domain of tan and sec. Tan and sec is undefined at 90. If it is undefined at 90, so it will be undefined at 3 pi by 2 also, that is 270. So see, r minus 2n plus 1 pi by 2, r minus 2n plus 1 pi by 2. 2n plus 1 always an odd number. So tan and sec domain is r minus odd multiple of pi by 2. Clear? Just you need to make a pair so that you remember the formulas or you remember this domain and range all the time. So tan and sec domain is r minus, see 2n plus 1, if n is equal to 0 it is pi by 2, if n is equal to 1 3 pi by 2, n is equal to 2 5 pi by 2, so 1 3 5 all are the odd numbers. So you can remember this as, okay, tan and sec domain is r minus odd multiple of pi by 2. Moving into the cot and cosec. Cot and cosec domain is r minus n pi, n pi. So it will be pi, 2 pi, 3 pi, 4 pi and all these things. So r minus, we can say it is only multiple of pi. Multiple of pi. So you need to make the pair like this. Sine cos, tan sec. Sine cos, tan sec. Then cot cosec. Clear? Moving into the range part. See, I have drawn a unit circle. Unit circle means a circle having the radius 1. Having the radius 1. Now, you need to remember this range part using the concept of unit circle. Unit circle, I will explain it in details soon. For till now, you can remember this. See, range is -1 to 1, closed interval -1 to 1. That means, if I set this circle, if I set this unit circle, I am setting the range of sine and cos. So this is the range of sine and cos. Now see cosec and cosec. Sec and cosec. It is a plane of real number. This is a plane of, I draw a circle, if you draw a circle, so it represents a plane. So outside this shaded region, it is a region of sec and cosec. Sec and cosec. And the entire plane is the range of tan and cot, because tan takes the value from -infinity to +infinity. Cot in the same way, range is -infinity to +infinity. So if I recap the concept, see, it is as easy to remember, because this concept requires, especially in the competitive examination, if you are eyeing for this, so you need to remember all this piece of information should be remembered very clearly. Inside, it is a unit circle. So once you turn, I am drawing a unit circle, that means 1, -1, 1 and -1. This circle, this shaded region is a range of, sine and cos. So outside means complement, that is r minus open interval -1 to 1, because we are covering the circumference also. That's why we are writing open interval. So this is the region of outside region. Outside the circle, region is for sec and cosec. And the entire piece of paper, it represents a plane of real number. So tan and cot range is r. So if I sum up the entire thing, sine cos r, domain is r, sine cos domain is r, tan sec domain is r minus odd multiple of pi by 2, r minus odd multiple, and cot and cosec domain is r minus multiple of pi. Then unit circle inside area with boundary, that is, it is a range of sine and cos. Outside sec cosec, entire plane, that is the plane of real number, represent the range of tan and cot. Clear? Now, in the next part, I am going to discuss all the inverse function with their graph and formula for all the inverse trigonometric function. Clear? Till then, goodbye.